Hi, my name is Perla Flores, and this is my constant velocity lab for Physics 1. In this lab, we were instructed to study Newton's second law, also known as the momentum principle. By examining the motion of an object moving in a straight line at constant velocity, we were tasked with using the app Tracker to record and analyze the object's position over time. Next, we were asked to create a computational model in Python GlowScript to predict the object's position versus time at constant velocity. Finally, we compared the experimental results with the computational model to determine how closely they agreed. Some key concepts that we need to know for this lab are the Newton's first law, which is an object will stay at rest if it's at rest. Newton's second law, also known as the momentum principle, states that an object motion depends on the net force acting on the object. If net force is zero, the object continues to move at a constant velocity, but if the net force is present, the object accelerates in the direction of the force. Some equations that we used in this lab were the velocity update formula and the position update formula and the average velocity formula and the FNEF. In this lab experiment, I used a marker as my object of motion and used a flat table as the place where the motion took place on. I also had a ruler on the side of it as a reference. I recorded the marker moving at constant motion and then uploaded it to the app Tracker. On Tracker, I tracked the marker's motion frame by frame. After this, it produced a position versus time graph as the marker moved throughout the video. Next, I had to create a computational model on GlowScript with the change in motion to compare the data to the recorded position. In this experiment, the system was the rolling expo marker, and the surroundings were the table, wind, and gravity, and etc. Here I have a video of my experiment. After uploading the video to Tracker, we used the red axis and the blue meter stick to be able to accurately get the position of the marker. The red dots show the tracked location as it moved throughout space. From this, we were able to get initial mass, initial position of the marker, and the initial velocity, which we calculated by final position minus initial position over the change in time. Our initial time was 0. Our final time was 1.267 seconds. Our change in time for each step was 0.033 seconds. Then after getting all of our information, I plugged in the information from the Tracker app into the GlowScript code, which was already given to us. I changed the mass to 0.07 because I wanted to use the mass of an actual expo marker. Here is the position which we got from the Tracker app and also the velocity that was calculated in the previous slide. My delta t, which was 0.033 seconds. And then in our while loop, we looped until the very last time, which was 1.267. And then here is where we use the velocity update formula, and we also use the position update formula right over here. Then I compared my Tracker results versus my computational results by putting both their position versus time graphs on the same one. Both lines show position decreasing as time increases. They begin at the same starting point, and they both have negative slopes. Some differences are that the orange expected line drops more steeply, meaning it predicts a faster movement, while the blue one decreases more slowly, so the object didn't fall as far as expected. As time goes on, the gap between them gets bigger. By looking at our graph, we see a difference in our results. This could be from possible errors of position tracker and rounding errors and outside forces. My current axes are where the marker is moving at a negative x direction with a negative slope. If I were to flex my axis, my velocity will become positive, but it will stay the same, and the slope of my line will become positive. Since we know that the object is moving with constant forces, there is no net force. But it is hard for us to know all the individual forces that are acting on the marker because they are canceling out with each other.